we are going to be moving on to multiplying like bases by like bases and problems that involve that skill. Let's make this bigger. So, the first thing we need to remind ourselves is what are the parts of a power called, because we're talking about multiplying powers with the same base, so we really need to know what is the base of a power. So 10 to the third power, this entire thing, remember we said, is called a power. Or we could call it an exponential expression. I'm not going to write that all right. Exponential expression. But usually we call it a power. All right? Only time you call it an exponential expression is if you're in math class, probably. All right. So this number, what's the 3 called? What's the 3 called? Cole? The exponent. But we can also call it a power, which is quite confusing, right? Just the exponent or the power. Now, what is 10 called? Yeah, that's the base. So the number that we're multiplying by the number of times that the exponent tells us is the base. So for multiplying powers with the same base, we have a shortcut. And that shortcut is we could just add the exponents. So if I have 10 to the third power times 10 to the 9th power, what they're saying is I can just take 10 to the 3 plus 9th power, or 10 to the 12th power. Does that make sense, Kendall? Why is that possible? Well, real quickly, why does that work? We're going to do a smaller number so you can see. 10 to the first power times, 10 to the second power times 10 to the first power. What's 10 to the second power, guys? 100, right? And that's times 10. So 100 times 10 is 1,000. And the other way we could look at it is that's 10 squared, right? So 10 times 10, that's 10 squared, times 10 more, right? 10 times 10 times 10 is also 1,000. Does that make sense? Now, the shortcut says we can take 10 to the 2 plus the first power. So let's do that on our calculator. Do 10, y to the x button 3, or actually you guys have an x cubed button. 10 x cubed, and you'll see that that is also 1,000. So for numerical bases, it's not that big a deal because we can use our calculator. But we're going to be also doing algebraic bases, or bases that are variables. So it's important that we know that shortcut. So if we're looking here at the next example, all powers have the same base. So here, there's a power 3 to the 4th, a power 3 to the 2nd, a power 3 to the 3rd, right? Remember, we could also read this as 3 squared and this is 3 cubed. All powers have the same base, so we're going to add those exponents. So it's going to be 3 to the 4 plus 2 plus 3 power. So it's going to be 3 to the 9th power. And now we can use our calculator. And we'll see that that's $19,683. And that's what we simplified here. So this is a simplified. So we added the exponents here, and then we simplified here. Any questions? All right, so let's look at this example on B. Are all the bases the same? 11 to the negative third, 11 to the fourth, times 11 to the negative fifth. All of those are the same. So we're going to add the exponents. For some reason, I messed that up. Oh, no, there it is right there. Awkward. So here we're going to rewrite this as 11 raised to the negative 3 plus 4 plus negative 5. So we can do that on our calculator. Negative 3 plus 4 plus negative 5. Remember, 3 negative button plus 4 plus 5 negative button equals, and you should get negative 4. Does that make sense? All right, and then we're going to simplify. So if we simplify, remember that's going to be, we're going to make that a fraction and move it to the bottom, make it positive if there's nothing left in the top. So we're going to put 1 divided by, nope, I lied. 11 raised to the 4th power is 14,641, so it will be 1 over 14,641. Any questions? So we are going to use have some problems that have variable-like bases. So let's try this example: x squared times x to the 7th. What is x squared times x to the 7th? Well, our bases are both x's, so now we can add the exponents, and now we know that that adds x to the 9th. If you're wondering why that's so, remember that's x times x, and this is x 7 times, right? So if we multiply all those, we have 9 x's. We don't want to have to count them. It's easier just to add those exponents. Does that make sense to everyone? See? All right. You can actually look at one of your homework problems, or just look at some of your problems on your worksheet. Once again, remember, we're not doing 33 through 36, and we're not doing 50. So we're going to do the back in just a second. Yes, we are. But let's do one that looks a little bit different. Let's do number 8 on your worksheet together now. Do you have an example of something that looks like that? So number 8 is negative 4 times k to the negative 3rd power times 6k to the 4th power. I don't know why I put a parentheses there. It doesn't have one. So we can use this new shortcut we learned. If they have a like base, then we can just add the exponents on these variables. You got to be careful though. What is the base? How many bases are in that expression? How many bases do you see? Yeah, not 1. Not 2. You could say 4, but 2 of them are the same, right? So remember, this is the same, and I'd like you to write this just one time. You don't have to do this if you don't need to on your homework, but I want you to see. Remember that this expression is the same as that expression. This is what that expression means, right? What is the exponent on the 4 here? Negative 4. 1. We don't see it. What's the exponent on the 6? 1. So we have 4 bases only 3 of them are different. So this is a base, -4. This is a base 6. This is a base K. This is a base K. Yes. We are going to be multiplying the coefficients. So I'm going to rearrange them and just put the ones that are alike together. So now it looks more obvious that we multiply those, right? Does that make sense, Zion? Does that make sense, Brandon? All right. And now we can use our shortcut. So it's going to be times K raised to the -3rd plus the 4th power, because those are both K's. So that simplifies to -24K, -3 plus 4 is a +1. We're not going to write our 1 there, so we'll just leave it like that. Does that make sense, Keyshawn? Does that make sense, Anson? Okay. All right. I think there was another one we were going to do. We're not going to do 16. You are going to do 16 on your homework. We're going to go over scientific notation in a minute, and we haven't done that yet. So we're going to do, let's do number 14 together. That's another one of your homework problems, so we're cutting out some problems, but I need you to know how to do it. I want to make sure that we go over it together. So let's look at this number 14 on your homework. We're literally doing a homework problem. That doesn't mean you can't try this problem on your own later, though, because you can, right? You can rewrite it and try it on another piece of paper to make sure you get the practice. But if we have this expression, 6a cubed times b to the -2nd power times -4a times b to the -8th power, remember, we can separate this out. And you may be able to do this in your head, and that's okay if you can. I just want to make sure everyone is clear. We do stuff in our head sometimes, but in essence, what we're doing is we're separating them and we're regrouping them. All right, so I'm going to put my coefficients together again. And now I've got A and A, so I'm going to do times A cubed times A, right? And then I'm going to do times b to the -2 times b to the -8. So all I've done at this point is separated them so we can see that they're individual factors. We rearrange them to put the coefficients together and the like bases together. The coefficients don't have like bases. We just multiply those like normal. What's the exponent on this a here if we don't see it? 1, right? So this is going to be -24a raised to the 3 plus 1 power b raised to the -2 plus -8 power. Is everybody following me? Any questions about here? All right, so now we're going to simplify that. It's going to be -24a to the 4th power -24a to the 4th power times b to the -10th power. But can we leave it as b to the -10th power? So we leave the only time we can leave a negative exponent in there is if we have scientific notation, and this one isn't written in scientific notation, right? There's no 10 in it. So now we're going to make it a fraction. We're going to leave our positive exponents where they are. And what are we going to do with the b to the -10th power? Move it to the bottom, that's right, and make it positive. And so that would be your final answer. Okay? Brooklyn, does that make sense? Yes. Yes, or I guess? Yes, okay. All right, any questions on that? So now we are going to go back to our notes and look at the scientific notation. Let's see, what is this? Okay, so the first thing we need to remember when you have scientific notation, remember it's going to be some number times 10 to some power, remember? And we have to remember that that number, that first blank, has to be between 1, greater than or equal to 1 and less than 10. Well, yeah. So this is an example of two expressions that are written in scientific notation, and they're asking us to multiply them. 1.8, that's between 1 and 10, times 10 to the 11th power, so that's in scientific notation. 2.7 times 10 to the 8th power, 2.7 is between 1 and 10, so it's in scientific notation. Does that make sense? We're going to flip over. I did this twice first period. I don't need to do it twice. All right. So the question is, what is the simplified form of 1.8 times 10 to the 11th power times 2.7 times 10 to the 8th power? We want to write the answer in scientific notation. If they give you the answer in scientific notation, or the problem in scientific notation, they don't tell you any other way, you should always give it in scientific notation at the end. Rearrange the factors. So the first thing we're going to do is going to rearrange the factors without the so that the factors without the exponent are grouped. So that first number. So here, all of you guys get caught up. And the numbers that are powers of 10 are grouped. See if I can make it bigger. Okay. So rearrange means we're going to take the 1.8 times the 2.7. We can put those in a grouping symbol or not. Let's do that. And that's going to be times 10 to the 11th power times 10 to the 8th power. Does that make sense to everyone? So now, we've rearranged. Now we're going to multiply. We're going to multiply the numbers in the first set of parentheses, and we're going to add the exponents to the powers of 10. So for here, 1.8 times 2.7, I think it's 4.5, I can't remember. No, 4.86. So that's going to be 4.86. Now we want it in scientific notation, so we're putting our big X back. And now this is going to be 10 to the 11 plus the 8th power. So that would be 4.6 times 10 to the 19th power. Yes. So remember, scientific notation, some number, big X, times 10 to some power. Okay? Remember, if the number is negative, it's less than 1. If the number is positive, then it's greater than 1, or that exponent, rather. If the exponent is negative, that's the only time you can have a negative exponent in your answer is when it's written in scientific notation. Or if they specifically say, write it with a negative exponent, which I always hate when they do that. Here's the deal. Sometimes when you multiply these, you get a number. So this answer, 4.6 times 10 to the 19th power, it's in scientific notation now because that 4.6 falls in between 1 and 10, right? So sometimes you're going to multiply those and they're either going to be bigger than 10 or less than 1. And then we have to fix it to get it in scientific notation. So we are going to do some examples from your homework like that, I think. Let me see what I got down here first. Oh, I was going to remind you how to use the calculator to add fractions. So if we're adding 2/5 plus 3/7, let's say. Remember, on our calculator, it's 2 ABC5 plus 3 ABC7 and equals. Okay? So everybody gets kind of freaked out when they see fractions as exponents, but it's exactly the same thing. And since we get to use a calculator, there's no reason to let it freak you out. So if you add those together on your calculator, it's 29/35. You don't have to do any rewriting with common denominator and converting to equivalent fractions. You don't have to do any of that. All you do is plug it in on your calculator. Any questions on that part? Did I ever cover everything here? Oh, up here it says, even when an expression contains negative or rational. So rational exponents, that just means fractions, or decimals, but we're going to see them as fractions. So rational number, they're usually referring to a fraction or a decimal. In our case, we're going to be talking about the fractions more. So let's do an example on your homework. Well, first off, let's start with an example. On the back, let's just go ahead and do, let's do number 40, because that's one that it won't be in scientific notation at first. We have to rearrange. So we're literally doing your third homework problem. So we're reducing your homework right now, so you should be paying attention. So let's go ahead, 0.8 times 10 to the 5th power times 0.6 times 10 to the negative 17th power. So in our notes, it says we're going to rearrange them, right? So let's do that. So we're going to put these next to each other. 0.8 times 0.6. And then we're going to put these next to each other. 10 to the 5th times 10 to the negative 17th power. So far, so good? Does that make sense, Lee? Does that make sense, Jeremiah? Does that make sense, Jaden? Okay. So now we're going to multiply this on our calculator. We're going to get 0.48. And we're moving back to scientific notation now, so times 10 to the 5th plus the negative 17th power. So I'm going to put it here. So now we have 0.48 times 10 to the negative 12th power. So the negative power is not a problem here. But this expression is not written in standard or scientific notation because 48 is not between 1 and 10. Kendall, does that make sense? So what we're going to do is we're going to rewrite this expression this expression in scientific notation, and we learned how to do that. So we're going to have some number times 10 to some power. We're going to rewrite this. But we can't forget, we already have times 10 to the negative 12 power here. So this is only going to be for the 0.48. Does that make sense, Fatima? Does that make sense, Paul? Yeah. All right. So now we talked yesterday about how do we rewrite this, right? So this is less than 1, so we know we're going to have a negative exponent, right? So we talked about find the decimal point and then move it. If I move it once, now that would be 4.8. Is that between 1 and 10? It is, right? So if I move it one time, that's my new number, and now it's negative 1. So however many times I move the decimal place, that's the exponent I write there. Does that make sense, Keyshawn? So now we just have to simplify these powers of 10 again. So now we have, so now we have 4.8 times 10 to the negative first plus negative 12th, or 4.8 times 10 to the negative 13th. You have to show me some work on these. Yes. So if you understand how to do that here, you can do that, yes. In essence, what you're doing this right here, you're just doing it in your head, right? Yes. In just a second. All right. Any questions on number 40? Let's go back to number 18. So what if it has a fraction as an exponent? If it has a fraction as an exponent, let's look at number 18 at 16 to the 1/4 power. Everybody back on the other side? We're doing another one of your homework problems. 16 to the 1/4 power. Anytime you have an exponent that's a fraction less than 1, we know that it's going to simplify to something less than this base. So that's one of the things you can check for. But we can just put this in on my calculator. 16, y to the x button, parentheses 1, ABC, for close parentheses, and equals. And tell me what you get. So if you can't get 2, you got to try it again. You could also do 1 divided by 4 there. Either way. So you're just going to use your calculator on these. You may want to make your notes, make a note to yourself on there. And I think I did one more problem with first period. So let's look at number 24. Anybody have questions on 18? Brooklyn, did you get 2? Okay. Corey, did you get 2? I don't see a calculator, Corey. Okay, great. Aiden, did you get 2? All right, great. So let's look at 24. 7 to the 34th power. Oh, 4/3 power. Times 6r to the 3/5 power. So we can rearrange this. 7 times 6 times, oh, I lied. Don't rearrange yet. That's not the whole problem, is it? Okay. 6 times 7q to the 1/3 times 6r to the 3/5. Pretty messy, but you guys have that problem there. So let's rearrange. Coefficient, 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 coefficient. 7 times 7 times 6 times 6. Now we're going to put our like bases, the q's together. Q to the 4/3 power times q to the 1/3 power. Right, so we've done all those. We got rid of our q's. It's a good idea to kind of mark things when you're rearranging, make sure you don't forget something. Now, times r to the 3/5 power times, oh, that's a 1/5 power there. Make sure you wrote the problem correctly because your teacher did not. Times r to the 1/5 power. So we're going to multiply all these on our calculator. Sorry? Here? Here? 1/5, yeah. You can look at the problem and see that, yeah, that's 1/5. So this is 1764 Q. Now we're going to do 4/3 plus 1/3. That's our new power. R, 3/5 plus 1/5. That would be our new power. So these have like bases. We should be able to do these in our head. But remember, your calculator will do it. 1764 Q, 4 ABC3 plus 1 ABC3. You should see that that is 5/3. And our exponent on our R's, 3 ABC5 plus 1 ABC5. Even if you can't, if you're not comfortable adding like denominators, your calculator will do it for you. Any questions? I think we covered everything I did in first period. 28, 30, and 32, those are kind of like puzzles. You're going to figure out what's going to go in that box. I'm not going to do one of those. You guys should do your best. Remember, think of it as a puzzle.